Okay, here we go with scientific notation. Today's notes are going to be taped into your notebook, page 103 and 104, once you get them filled in. Scientific notation, it's a shorthand way of writing really large numbers or numbers that are really, really small. Scientific notation is actually a product of two numbers. The first number must be between 1 and 10, and the second number must be a power of 10. So to create or to convert standard to scientific, we first again have to make the number between 1 and 10. You're simply just going to move the decimal point over to get that number between 1 and 10. And then you're going to count the number of times that you moved your decimal point. This number ends up being your power or your exponent that you'll put on your 10. If the number is greater than 1, you're going to have a positive exponent. If the number is less than 1, the exponent will be negative, and we'll see some examples of that in a second. So for the first example, you actually have the number 1,850,000, and it takes up a lot of space. It's considered a large number. It's going to have a positive exponent when we're done. Currently, the decimal point is all the way at the end of this whole number, and the commas help separate the place values so you can talk about the number and know its value. When you move this decimal point, you're going to move it all the way over so that you have the value 1.85. 1.85 is a number that's between 1 and 10. We couldn't use 18.5 and we didn't want to use 185 because those values are too large. We needed a number that is between 1 and 10, and that's how you create it, by moving your decimal point between the digits that are not zeros. The digits that are zeros and the digits that we have place values for get replaced with this part of the scientific notation. We're timesing by 10, and the exponent we're going to use is the number of places that we moved over. So you can kind of see these little marks I made on the paper. There's 3, there's 4, there's 5, there's 6. We moved the decimal point 6 places to get it between the 1 and the 85. So that means if we do 1.85 times 10 to the 6, we will have the same value of the number. But this is considered scientific notation. It's considered the notation that would be used by scientists and mathematicians to work with a number that is really, really large or really, really small, like we see in this example down here. We're going to do another large number question though, so we get used to doing those first. Here's your decimal point. You're moving it over to create a number that is between 1 and 10. The number that we create that's between 1 and 10 is going to be 4.2. 4.2 is then going to have this times 10. And again, we count the spaces that we moved the decimal point. 1, 2, 3, we moved it 4 places. You're keeping your exponent positive because we're dealing with a positive large number. So 4.2 times 10 to the 4th would be, again, what we would use for scientific notation. This number was originally given to us in what's called standard notation. Numbers can come to us that are very, very small decimals like this one, but they also take up a lot of space. So what we're allowed to do with scientific notation is we're also allowed to move the decimal point to get it in between digits of a small, small number like this one. So the number that we create that's between 1 and 10 is going to be 7.826. You always have to grab all the digits that aren't zeros. And then to take care of the movement that you made with the decimal points, remember you're multiplying by 10, and you're going to have an exponent of this time -3. We moved the decimal point 3 places. The reason it's a -3 is because you're dealing with a small, small decimal. Okay, small decimals are always going to have a -3 exponent. So there's that, 7.826 times 10 to the -3 power. We're going to have a negative exponent on this one also because we have a small, small number. And what we have to do is we have to move our decimal point quite a ways to get our decimal behind the number 1 is the only digit that we've been given in this problem. And again, it has to be between 1 and 10. So we could put a 0 here if we wanted to, but we wouldn't have to. We could just leave it 1. And then we're again multiplying by 10. Every time you multiply by 10, you're moving a place value over. So there's 1, 2, 3, 4. We moved it 5 places. So this time, remember, you're using a -5 as your exponent to show that you've moved it 5 places and to show that you've got a very, very small decimal. So earlier we said we didn't have to put 1.0 up front. We could just put a 1 here, and that's what you'll see on the paper. 1 times 10 to the negative 5th power. Now, when you have to convert from scientific notation to a standard number, we're going to move the decimal the same number of places as the exponent tells us. If we have an exponent that's positive, we're going to move the decimal point to the right in order to get the large number that's supposed to represent. If our exponent is negative, we're going to have to make sure we move the decimal to the left in order to make sure that we're dealing with a small decimal number. So here's some examples. The first one says we have this decimal times 10 to the 7th power. This means we're taking our decimal point and we're moving it 7 places. Now, after you move it to the right twice, you're running out of digits. So what we have to do is we have to put placeholder zeros. Let's make sure we have 7 all together. There's 1, 2, there's 3, 4, 5, 6, 7. So what this looks like is we're going to have 7, we're going to have our 8, 3, and then we're going to have to make sure we have place value zeros for those 5 digits, or for those 5 places that we ran out of room with our original decimal. So this would represent 7.83 times 10 to the 7th because we've moved it to the right 7 places. And if you wanted to, with a large number like this, you can put your commas in. Just make sure your commas don't look like decimal points. So again, this is considered standard notation for a number. This is considered scientific notation because we're taking a decimal times 10 to some power. This also has a positive exponent, so we're moving our decimal point to the right. This time we only move it to the right 4 places because our exponent's a 4. What this means is after moving it past the 5, the first digit that we used, we only need 3 placeholder zeros behind it to guarantee that our number represents 25,000. Again, standard notation, scientific notation. The last 2 examples have negative exponents. So remember, a negative exponent is going to take you to the left with your movement of your decimal point. So far we had to move it 1 place to get in front of the 8, and that means we need 5 more movements to get to where your decimal point is ultimately going to be. That means we need 5 placeholder zeros to guarantee that the value of this number is exactly what it's supposed to be. So we end up with 0.00000834. It's a very, very small decimal number, and that's what's indicated by this little negative exponent. Number 8's a little tricky because you're given the whole number 3. Whole number, remember, has a decimal point right there to its right. So if we have an exponent of negative 3, we have to move the decimal point 3 places to our left. When you do that, the first place value of moving it in front of the 3 takes up a spot, and then we have 2 more empty spots that need to be placeholder zeros. So this has a value of 0.003. What you're going to do now is you're going to practice taking numbers in standard notation, writing them in scientific notation, and then you're going to take your scientific notation and write them in standard notation as well. Keep in mind the large numbers like these 2 are going to have positive exponents, and when you have a negative exponent, like in this case, it's going to move your decimal point to the left. So pause the video, give those a try, jot down your answers, and then go ahead and play, and we'll go over them. For the first one, you needed to move the decimal point all the way in between the 5 and the 82, so that's why your decimal part is 5.82. You moved it 6 places, and it's a positive 6 because you have it being a positive large number. The next one gave us a positive 5, so we needed to move our decimal point this way 5 places, and that's why you ended up with 3 placeholder zeros behind the digits for 25. In this case, we needed to move our decimal point 3 places to get it between the 1 and the 2. It's a positive large number, so that's why we have a positive 3 exponent. For this one, we needed to move the decimal point 7 places to the left. Moving it in front of the 6 takes up 1 spot, so after that we should have 6 placeholder zeros in front of it, and then the digits. This one needed to go between the 1 and the 5 with our decimal point. So that's why we've got 1.5, and we ended up moving it 3 places, so we used a negative 3 to represent that it's a small decimal. And what you have now is to work on the last page for your notes. This page, again, has numbers that are in standard notation, and it has numbers that are already in scientific notation that you're going to convert back and forth. Be very careful with the negative exponents. Again, pause the video, practice these, and then play it to check your answers. For the first one, positive exponent, you moved it 7 places. There's 3, there's 6, there's 7 to get it to be between the 7 and the 6. Again, the other digits are important, so you just have to jot them all down. Times 10 to the 7th power. This one, you had to move your decimal point between the 3 and the 27, but it's a -4 because you've moved it 4 places and you're dealing with a small decimal. This one moved 4 places to get it between the 3 and the 4, but it's a +4 this time because you're dealing with a large number, 34,000. Another large number, you had to move this decimal point 11 spots to get it to where you wanted it to be between those ones, so 1.16 times 10 to the 11th. And then this last one in this column, you had to move your decimal point 5 places. So you have 9 times 10 to the 5th. Again, large number, positive exponent. When you have negative exponent, it means you have to move the decimal point to the left to get the standard notation. This is a small decimal, 0.024, but it can be written as 2.4 times 10 to the -2. This exponent's positive, so notice how we went to the right with our movement to make the number 2800. It's a positive large number. Another positive large number where you had to move the decimal point beyond the 1 7 places. This guaranteed us 7 zeros. This one's a negative exponent, so again we have to move it this way, and you're going to move it a total of 6 places, which in this case is going to allow for 5 placeholder zeros because you had to move the decimal point in front of the 9. And for the last one, we have to move it 3 places to the left because of the negative exponent. You get a lot of decimals down here on this one to practice with. So tape your notes into your book. If you have questions for me, let me know.